Good morning, students. In this lecture, I want to discuss some formulas, students. Or students, some formulas. Let us see. Say, this is very, very important, students. Fourier integral in complex form. What, students? Fourier integral in complex form. The proof is important, students. So, f of x that is equal to 1 by 2 pi integral minus infinity to infinity integral minus infinity to infinity f of t e power I lambda t minus x dt d lambda dt d lambda. This is statement, students. So, solution we know Fourier integral, students. What, students? Fourier integral. What is Fourier integral, students? F of x that is equal to 1 by pi integral 0 to infinity integral minus infinity to infinity f of t cos lambda into t minus x dt d lambda dt d lambda. So this is one, students. Once again, Fourier integral, students. F of x that is equal to 1 by pi integral 0 to infinity integral minus infinity to infinity f of t cos lambda of t minus x dt d lambda dt d lambda. Now I observe the integration, students. We have here minus infinity to infinity. What, students? Minus infinity to infinity. So I want to convert into 0 to infinity into minus infinity to infinity, students. I have a formula, students, here. What is formula? Integral minus a to a f of x dx that is equal, students, 2 into integral 0 to a f of x dx. When it is whole, students, f of x is even. F of x is even. Now I am assuming f of x is even. Okay, students, cos x also a even. So if cos lambda into t minus x, not if, students, cos lambda into t minus x is even, students. Cos lambda into t minus x is even. So this can be written as f of x that is equal to 0 to infinity can be written as, students, 0 to a f of x dx can be written as 1 by 2 into integral minus a to a f of x dx. Okay, students. So this can be written as 1 by 2 pi integral minus infinity to infinity integral minus infinity to infinity f of t cos lambda into t minus x dt d lambda dt d lambda. So this is 2, students. This is 2. Now cos is even, students, but sine is sine lambda into t minus x is odd, students. Odd. Now whenever f of x is odd, what is the integration value, students? Integration value 0. Integration value is 0. So function value is 0, students. So this value is 0 here, 0. That is equal to, I can write it as 1 by 2 pi integral minus infinity to infinity integral minus infinity to infinity f of t sine lambda into t minus x dt d lambda dt d lambda. So this is 3, students. 3. So we have a formula, students. That is, formula is e power I theta that is equal to cos theta plus I sin theta. What, students? E power I theta is equal to cos theta plus I sin theta. So I want to get e power I lambda into t minus x. So come on, tell me, students, here 2. Very good. 2 plus the sine term quotient contains I, students. So multiply with I, students. I into 3. We get. So we are adding these two. So f of x that is equal to 1 by pi is common. 1 by 2 pi is common, students. 1 by 2 pi integral minus infinity infinity integral minus infinity infinity. What is common factor, students? F of t. Here cos lambda into t minus x plus I into sine lambda into t minus x into dt d lambda, dt d lambda. So that is equal to 1 by 2 pi integral minus infinity infinity integral minus infinity infinity f of t. This can be written as, students, e power I theta. So e power I into, what is theta, students, here? Lambda into t minus x into dt d lambda, dt d lambda. This is our complex form of Fourier integral. Complex form of Fourier integral. Let us see some other definition, students. Fourier transform. Fourier transform. Now this Fourier transform you get from complex form of Fourier integral, students. Let us see here f of x, that is equal to 1 by 2 pi integral minus infinity infinity integral minus infinity infinity f of t e power I lambda, multiply with I lambda t. This is like a power m minus n, students. So a power m into a power minus n. So e power I lambda t into e power I lambda minus x. So minus x into dt d lambda, dt d lambda. So 1 by 2 pi integral minus infinity infinity integral minus infinity infinity e power minus I lambda x, e power minus I lambda x integral minus infinity infinity f of t e power I lambda t into dt into d lambda, into d lambda. So students, once again I multiply with I lambda and separate the term, students, and rearrange the terms like this, students. Now this part is called Fourier transform. Fourier transform. Now come on, tell me, students, Fourier transform. Fourier transform. So Fourier transform, the first letter is, students, f, students. So f of fx, students, is denoted by f of fx. That is equal, it is also denoted by f of s, students, f of s. So integral, what are the limits, students? Minus infinity to infinity. Minus infinity to infinity. I want to write x, students. So f of x e power I s x dx. I want to write s in place of lambda, students. S in place of lambda. So this is our Fourier transform, students. F of x, that is equal to integral minus infinity infinity f of x e power isx dx, isx dx. Now inverse Fourier transform, students. Inverse Fourier transform. Inverse Fourier transform. Say inverse Fourier transform means you just substitute here Fourier transform is f of s, you just substitute here f of s, then you got inverse Fourier transform, students. So this is f of x, students. So f of x, that is equal to 1 by, we have here 1 by 2 pi, for the integration, students, integral minus infinity to infinity, this integration value, students, f of s. So write f of s, students, f of s, and e power minus I lambda means, students, yes. So s x into ds. Once again, students, f of x, that is equal to 1 by 2 pi integral minus infinity to infinity f of s e power minus isx ds. E power minus isx ds. This is inverse Fourier transform, students. Are you understand, students? How can we get Fourier transform, inverse Fourier transform? Very good. Now let us see some more definition, students. Fourier Sine transform. Or, students, Fourier Sine transform. It is denoted by, students, Fourier transform means f of s. Fourier Sine, students. So what is sine? First letter is s, students. So fs of s. The notation is fs of s. That is equal to integral 0 to infinity f of x sin sx ds. Sin sx dx. Fourier transform means we get always x, students. Inverse Fourier transform means we get ds. Okay, students. Now inverse Fourier Sine transform. Inverse Fourier Sine transform. Now inverse means we get here, students, always f of x. So that is equal to 2 by pi integral 0 to infinity. Now this time, students, inverse means we get here f of s. So we get here, students, fs of s sin sx. This time get ds. Now Fourier cosine transform, students. Fourier cosine transform. Fourier cosine transform. Now sine means fs of s, students. Cosine means fc of s. Fc of s. That is equal to, what is formula, students, here? Integral 0 to infinity f of x. You write simply cos, students. So cos sx dx. Cos sx dx. Now inverse Fourier cosine transform. Inverse Fourier cosine transform. Inverse Fourier cosine transform, again, students, f of x. Okay, f of x, that is equal to, same, students, 2 by pi integral 0 to infinity. This time you get here, students, fc of s. Fc of s into cos sx into, students, ds. Once again, students, Fourier transform is f of s, that is equal to integral minus infinity to infinity f of x e power isx dx. Fourier transform means we get dx, students. Inverse Fourier transform we get ds. So f of x, that is equal to 1 by 2 pi integral minus infinity to infinity f of s e power minus isx ds. Minus isx dx. Fourier sine transform, students. It is denoted by fs of s, that is equal to integral 0 to infinity f of x. Sine means we get sin sx dx. Inverse means, students, f of x, that is equal, we have extra term, students, 2 by pi integral 0 to infinity fs of s. Fs of s, students, here please remember sin sx. This time here, students, ds. Inverse means we get ds. Similarly, Fourier cosine and inverse Fourier cosine transform, students. Hope you understand. Thank you for watching this video. Jai Hind.